Fare you well, my honey. Fare you well, my only true one. All the birds that were singing are flown except you alone. Going to leave this broke down palace on my hands and my knees. I will roll, make myself a bed by the waterside. In my time, I will roll. In a bed by the waterside, I will lay my head. Listen to the river sing sweet songs to rock my soul. River, don't you take me, sing me sweet and sleepy. Sing me sweet and sleepy all the way back home. It's a far gone lullaby song many years ago. Mama, mama, many worlds I've come since I first left home. Going home by the waterside, I will rest my bones. Listen to the river sing sweet songs to rock my soul.
Workin Bridges started as a collaboration between Box Steel and our nonprofit in Iowa after our bowstring was swept off of its piers in August of 2010. So just as they were finishing up this bridge, our bridge was being swept off of its piers, and Box Steel's Nels Rayner came to Iowa to pull that bridge out of the river, and that's how we started our collaboration. So he is one of the foremost experts on the restoration of wrought iron bridges, and those bridges were built between the late 1860s through the late 1800s.
There you will, I love you more than words can tell. Listen to the river sing sweet songs to rock my soul.
We started out with TxDOT telling us we needed work on this bridge, and I'll be honest with you, we didn't know where to start. I mean, this is an old bridge that not a lot of people had expertise in, and we basically closed it off and started looking, and we didn't have a lot of luck finding things, but I think the judge and maybe his office got us on the internet, which is something that they do well, and they put that out there for a lot of people to see, and Bauer Bridge gave us a call and said that this is what they do. So the next step was to get them down here. I mean, you know, you were the only people that told us that you could do it, so we said, well, let's get them down here and we'll take a look at it. So we did, and we met y'all out here at the bridge, and when I walked out, I remember seeing Nels up on top, and a little scary, but that's Snell. But anyway, we got a lot of information from y'all just being here those few days. Told us exactly what we had, the situation we were in, and basically liked what we heard. We were going to get a bridge that was somebody knew what they were doing to fix it, and so we just went with it now. And I think probably being that y'all were out here going to do something with our bridge, got TxDOT kind of noticed that and decided they wanted to get in on that also. So I think when TxDOT got here, it turned out to be a win-win-win. It was a win for us, a win for TxDOT, and the bridge people that came to visit us the first time also got a piece of the pie, which is great. So that's where we're at today. And like I said, I just think all the pieces fell into place. It was just the way it should be. And now we're getting our new bridge. It's going to be a bridge that looks and works like it did when it was brand new. We know every part's going to be right, safe, and the people should be very happy with what we end up with.
Hi, welcome to the Piano Bridge. We're here waiting for restoration. It starts next week. So excited. Workin Bridges stood on this bridge last year with the county of Fayette here in Texas, and TxDOT engineers and Box Steel's Nels Rayner and Rick Welsh of Penta Engineering while we tried to come up with an estimate for the repair in place of this bridge.
In Michigan, we'll replace all of this. All the pin plate.
And everything.
Pin plate, we'll cut this off right here, the back plate, because this will all be rotten in Michigan. So we'll cut this right here, we'll replace that channel. Exactly.
Well, when we first came down, we were contacted to take a look at the fact that this engineer had closed this bridge down and see what we thought the problem was and whether it could be repaired. We came down and gave them numbers on that, and TxDOT had some involvement at the time, and then they stepped up to the plate, and because I knew Davis Construction had an office down here, we bid it through Davis with practically the same numbers as what we came up with in the original, and ended up coming down and doing probably more than what really needed to be done, but probably more of a thorough job, I would say. And not because we had decided to do it cheap, they wanted to know what had to be done to fix it, to get it back so they could open it. That was the big thing. They wanted their bridge back open. So my involvement as far as working on these bridges is that, for one thing, I don't do it just because there's money involved. I do it because I thoroughly enjoy working on old things, and I got involved in it, and I can do all of the metal part of it. I mean, I can heat straighten it, I can weld it, and of course I can rivet it. Being lifted with a single rig, and I've never done that. I've never lifted one of these, and without two cranes. And the neat thing about it is that when I talked to Charles Walker about it, is the spreaders that are being used are at the same angle as what the incline end posts are, which will leave some of it's just like a continuation of the incline end post. That was the theory behind it. So it being that we're seriously thinking that maybe we can do this on other projects too.
But you can't take it all. There are times when I can help you out, and times when you must fall. There are times when you must live in doubt, and I can't help it all. 3 blue stars rise on the hill. Say no more now, just be still.
set down on top of a couple pier tops and prepare it for disassembly.
Down by the breeze, you can walk on coals of fire, but sometimes you must freeze. There are times when you offend me, and I do the same to you. If we can or won't admit it, I guess we could be true. To start, sets on the hill, hold it back, you never will. But don't stop, sinks in the past. Show me something built to last.
Right now what they're doing is they're heating the pin nuts up and removing them so that they can remove the eye bars. And we'll use a combination of heat and penetrating oil usually. And the bad thing about some of the old bridges, like this is a U-bolt system, is that they're what is commonly called a cut nut. So it's a square nut, but it'll be 2.5 inches on one side and 2 1/4 on the other, so you can't just use a standard wrench. So typically what we'll do is we'll take those off with a pipe wrench. Whereas like the pin nuts, we'll make sockets to fit those or buy them.
Other times you gladly part with what you need to live. Don't waste your breath to save your face when you have done your best. And even more is asked of you. Fate will decide the rest. All the stars are gone but one. Morning breaks, here comes the sun. Close the sky, now sinking fast. Show me something built to last. 3 blue stars rise on the hill. Sunlit land up be still. All these trials soon be past. Look for something built to last. 1 blue star sets on the hill. Call it back, you never will. The stars now sinks in the past. Show me something built to last. All the stars are gone but one. Morning breaks, here comes the sun. Close the sky, now sinking fast. Show me something built to last.
There's going to be a lot of unforeseen things, and I think that that's where I talked to Charles Walker about it. I think that that's where the engineers on these projects could benefit from someone like me, because I can come in and say, look, I know it's not visible right now, but I guarantee you we're going to either have some section loss in this area, or cracks in this area, or this is going to have to be replaced. And I think that by doing that, we could the plans could be better filled so that we don't run into extras, because I know that that's one of the tough things, is that on this job in particular, you know, we've had a good handful of extras that weren't visible to the engineer. But if I could have had my hands in it, I could have brought it to their attention before the plans went out.
No bridge left here. It's all down. It only took 2.5, 3 days to disassemble a king iron bridge.
Bridge for an example. Now, the inspector came to me and says that we're doing the turn of the nut method on this bridge. So now we've already stuffed the bowl and we've tightened it with an impact. Now we have to go back and mark the bowl and then turn it 1/4 of a turn. And that entails having one guy doing the turning and an inspector on the job to watch us do it. And that's how we got the riveting to go on this job. Is their concern was that it was going to cost more if we riveted it, and I told them that it wouldn't be any more expensive, because if we have a process, if we have a lump sum where we can shoot 300 rivets, I can do it for just about the same cost as it would be, if not cheaper, than to do a turn of the nut method on all these, what they'd spec out as bolts on this job. So there's a lot of misnomers about riveting. As far as the process is fairly simple. You know, we take this particular job is mostly 5/8 rivets. We heat them up to about 1900 degrees and we drive them. The neat part is having to come up with different tools to be able to do different things, as far as what we call bucking. Riveting is really not that complicated, and it's really not something that you need some huge amount of guidance on. The unique part about, you have to have the ability to be able to look at the situation and be able to decide not how you're going to drive the rivet, but how you're going to buck the rivet, because you're putting a lot of pressure against the guy that's running a bucking bar. And we'll use a pneumatic holder on in some cases, or we'll use a bucking bar where you can actually cam it to where you're applying pressure to something underneath it or to its side to be able to hold the rivet in place. And if it's done properly, the amount of energy that the guy bucking it has to use is limited if the guy that's running the gun knows how to set the rivet, because it's the initial 3 hits in that sets that rivet, so that you don't have to, you know, hold on to it with some ungodly amount of strength. So riveting isn't used in today's society, or it lost its appeal in construction, not because riveting wasn't as good, but people realized that putting bolts in place of rivets or a welding process was a lot faster than applying rivets. So, and now it's kind of coming around full circle, because people are studying these things and they're finding out that the benefits of having a rivet versus a bolt. And I've said it once, I'll say it again, you know, it wasn't the rivets that failed on this bridge. It was the bolted connections that failed on this bridge, which caused the engineer to close it. So continuation of the shear right here is what caused not this particular plate, but the plate that was opposite of it to fail, because the bolts became loose. This was a bolted connection here, and this was a riveted connection, and the bolts became loose. As you can see, the holes are wallowed out, and it caused this continuation of this shear mark to continue to propagate up into this hole, and it cracked and failed. And that was the catastrophic failure in the bridge, which caused it to be closed.
And how was that repaired?
Charles Walker was the one that noticed the continuation of the shear marks on the plate. And how we repaired this was that We made a bigger plate than this with a leg that came down for the vertical that was a lot longer, and this continuation here was longer, and this had another series of, so they're just bigger plates and thicker to give it the redundancy that they were looking for. Well, the eye bars were, as far as what we're used to seeing, weren't that bad, but because this bridge is wrought iron, the actual, you know, the known ways of heat straightening are, you know, V-heat, and there's bulwark and stuff like that, but you got to be careful with wrought iron because there's a temperature in there where wrought iron becomes almost like wood and the material will separate. So we try to stay way below critical temperature. We actually don't use the heat to get a reaction from the material where you do with V-heat on mild steel. We use it more to relieve the stress in the material and make it more malleable so that we can work it. Because if you put too much heat to it, it just doesn't react the way mild steel does. A V heat process, you know, you get done, you heat it up in a V, you take the heat away, and you can watch the material slowly collapse on itself and take the bend out of it. Wrought iron won't do that. Okay, pull on a little bit, Shane. Okay, hold that.
We need to put a clamp behind it now.
No, I just want to let it cool just a little bit. Ask myself, if it was mine, would I be happy with it, you know? Down to, you know, doing ornamental work, would I put it in my house? And if I can't say yes to it, then I probably should take it back apart and do it again. Because, especially on a bridge, I think we have to hold our standards pretty high on bridges because there's people's lives involved in it. You know, I like the fact that I think the codes in Michigan are a lot stricter than they are here. You know, where we UT every weld I do and all that. But I like the fact that, you know, you got to be certified, you got to be qualified, and you're going to be inspected. I like that idea because that just, to me, that means that the company mechanic can't come out and throw a couple boogered up welds on something and call it good. I also like the fact that this is an in-kind restoration where, you know, we aren't welding a bunch of gusset plates on and sticking a bunch of A325 bolts in it. calling it restored, you know. To me, that's a rehab. That's not a restoration. So yeah, I think it would be to our benefit, because I think we're on the ground floor of something that's gonna eventually it's gonna blossom. There's so many of these bridges out there that could be utilized. I haven't really seen any scientific proof that older steel or older iron can't be welded. I don't know where those analogies are coming from, whether it's something that's proven. We've taken old steel and done bend tests to it, and it really doesn't make a lot of sense to me. I mean, any steel, whether it be new or old, can be bent past fatigue so that it would fail. But to just generalize everything and say, well, you can't weld that because it's wrought iron and old steel will fail, because that's not true. We've proven that you can even go as far as to say that you could take A320, A36 steel and weld it to wrought iron. I mean, so unless someone can show me some type of scientific proof that you can't weld old iron, I seem to do pretty good at it. There was some section loss. It wasn't critical, so we're pad welding over it, and we did that more for appearance and to prevent any further propagation of rust, and because it is a pad weld, it's a series of welds, so I have to chip and clean it pretty thorough to be able to do what we're doing. And what isn't shown is after we got done, we ground it out. There's a little bit of a die grinder where we used, but we flattened, and we didn't really notice or we would have done this prior to reinstalling that plate.
That the materials that we've got out there on this particular bridge are capable of sustaining that load pattern over several more decades to come. And so we're confident in it, and in our historic preservations across the state that we've been undertaking since the late 1980s. When we've restored bridges, we continue to monitor them and inspect them just like we do all of our bridges, and fatigue has not been an issue for us in those preservations.
Well, in those areas that are showing signs of distress and those indicators, we're removing them and replacing those parts, just like we're doing on this bridge. You know, there's some new metal in this bridge as they went through.
It's been beefed up a little.
You bet. You go through and you analyze each particular member. And I got to mention Charles Walker's name. He's an engineer that works for the Department of Transportation, and I think he's second to none, because there's not an inch of this bridge that he had scoured through and analyzed, understanding that we want this to be a very successful program, and we never want a bridge to fail. And I have utmost confidence in his abilities.
Maybe best able to be restored and maintained under some type of use, whether it's vehicular or pedestrian, or those that have gone too far. We really do look at it from a pure engineering cost analysis. Again, I think we're very blessed to have some very capable and extremely skilled engineers in historic bridges and their preservation techniques. They evaluate those with us, determine what the cost might be and what the adaptive use, if they weren't going to be able to be used for continued vehicular passage, might be. And it gives us then the opportunity to evaluate from a state perspective with the local entities when it's off our system. Is it a value to spend those resources and either move that structure to some other place, rehabilitate it and maintain it, or leave it in place? And if not, what are our alternatives in terms of documentation, preservation, and those archiving of that information? So it really does just come down to a cost analysis with the goal of always trying to preserve that structure first in place, and then if not in a restored location that can create kind of a museum environment. So we go into every historic bridge project with the goal of restoring it and leaving it in place.
Right down there, Rick Welch and me had gotten on top of the bridge, and we realized that each connection had a series of prick punch marks in it, and it was all assembled from one direction. So what we did that differed from how they disassembled it was that we built 2/3 of the bridge, each side of the truss, on the ground and stood it up, and then added the last third of the bridge afterwards. But we did that because we built the 2/3 and stood them up. We built those on the ground one day and then stood them up, and then put the sway braces and the lateral bracing in the top, and that box was secure. We could leave it overnight. We put everything together on the 2/3, and then we realized that our concern was that we couldn't hold the one set of eye bars, so we took some of the eye bars off and then reinstalled them after we stood the bridge up, because we were afraid that in the process of standing that truss up that we could possibly bend them. So, and the last thing we wanted to do was bend them. We spent a lot of time straightening all those eye bars on that bridge.
You know, the Minnesota bridge collapse on I-35 and that tragedy has certainly been well analyzed and documented, and while many people have used that as a battle cry to remove all old truss bridges, it's done out of sensationalism and hyperbole. As you mentioned, there were a lot of factors that played into that horrific event. There was a deficiency in one of the gusset plate designs. There was a failure during the inspection processes to understand the evolving condition of that gusset plate. And then there was a construction project underway that had dramatically changed the loading patterns on the bridge itself. And so to take that as an example and use it as the flagship to drive forward a desire to replace all old truss bridges is just misguided. Engineering is a science that understands the variables and then addresses those in a systematic, thoughtful, and methodical way. And what happened in Minnesota was a tragedy. No one can say otherwise. But there were a lot of circumstantial and compounding variables that led to that. And there are bridges that are truss bridges all over the world that have and continue to be successful. And will be. And then here in Texas, we take that opportunity to learn from that lesson and the loss of those lives to make sure that we are continuing to improve our inspection techniques, our monitoring processes, to make sure that we never have that type of compounding of variables replicated into a tragic situation here. And so that's the appropriate, in my opinion, direction to take, is to learn what you can from that tragedy and make sure that you don't replicate those circumstances in the future, but not have some knee-jerk hyperbole reaction to it.
It's been kind of the neat thing about this is that I'm so used to having engineers that are dead set against any contractor giving them any information, and what we've run into in these processes, whether it's been a blessing of the engineers that we've had or not. I mean, they actually ask us, what do you think? What do you think we can do here? And because it's thinking outside the box. It's old technology that's being dug back up, and no one has, there's the guys that did all this stuff aren't alive no more, so it's all new ground, even though it's old, I guess is what I'm trying to say. So the collaboration between the engineers and me, I've had good relationships with them, and this job in particular, Charles Walker and me have had quite a few conversations about what would be the best process to fix stuff, and I like that. because I think that I have a lot of good information that an engineer can benefit from, and they definitely have a lot of good information for me to benefit from. One of the unique things about Bach is that we're capable of doing all aspects of the restoration work. We can heat straighten. We're certified welders. We're qualified welders and riveters. And when I say that, there's a difference between being certified and being qualified as far as DOT is concerned. So, I mean, we have those qualifications. Whereas a lot of other companies have to outsource that, you know, whether it be the heat straightening has to be done by one company, and where the problem runs in with that is that we're there, and we could be welding on a floor beam and realize that we got some eye bars over here that are bent, and they have to go over and heat straighten them, and versus stopping and calling the other company or another company in to come in.
I think that it's an opportunity for groups like yours to reach out to us and to help us understand and appreciate what your values are and what your interests are. I know that in the area of the state that Mr. Poweshiek is given the opportunity to work with, there are a lot of individual citizens that understand and value the culture and the history of that particular part of our state. They have a rich understanding of that history and a deep appreciation for it. And so they reach out to him and early on and say, these are the bridges that we're interested in, or perhaps it may be an old department building that we first started working in an area under, or some other historic character. And they let us know way before it's ever an issue for us in terms of removing or replacing or I guess giving away an asset, that's of value and importance to them. So I guess I would encourage all groups that are interested in whether it's historic preservation of bridges or buildings, maybe the identification of old travel routes like Route 66 across our country, or the Chisholm Trail here in Texas. Maybe it's scenic beauty and things that they believe are important to having a quality of life that's rich and rewarding, to engage their local, state government entities, and to be willing to do that often and in a very robust manner. We like to know what is important to people. We believe that we're public servants. It's not our responsibility to dictate to the community, but it's to understand what their needs are, what their desires are, and then to come up with solutions to do that. You know, as engineers, what we believe is our mantra is this, that we can do for $1 what any fool can do for 10. And so if we know what people want, then it's our desire and our intent to try to make that happen within the confines of the state and federal laws and the funding that we have.
So far, everything's gone just fine. Just finishing up. They're tearing down the crane, just reset the bridge back to the position.
Any problems on this job?
Nothing significant, no ma'am.
Very good. Any real success stories?
Well, just getting it done seems like a success to me.
Well, the first days are the hardest days, don't you worry anymore. 'Cause when life looks like easy street, there is danger at your door. Think this through with me, let me know your mind. Oh, oh, what I want to know is, are you kind? It's a buck dancer's choice, my friend. You better take my advice. You know all the rules by now, and the fire from the eye. Will you come with me? Won't won't you come with me? Oh, oh, what I want to know, will you come with me? Goddamn, what I declare, have you seen the light? Their walls are built of cannonballs, their motto is don't tread on me. Come here, Uncle John's bed, playing to the tide. Come with me or go alone, he's come to take his children home. It's the same story you told me, it's the only one you know. Like the morning sun you come, and like the wind you go. Ain't no time to wait, barely time to wait. Oh, oh, what I want to know, where does the time go? I live in a silver man, beggars do. I got me a violin, I break it all the two. Anybody's choice, I can hear your voice. Oh, oh, what I want to know, how does the song go? Come here, Uncle John's band, playing to the time. Got some things to talk about here beside the rising tide. Come here, Uncle John's band, playing to the tide. Come on along and go, although he's come to take his children home. Want to know, how does the song go? Come here, Uncle John's band, by the riverside. Got some things to talk about here beside the rising tide. Come here, Uncle John's band, play